I'm the kind of person who likes mathematics, but who doesn't like calculating things. To me, that's just grindy. What's 13 times 8? Meh. That's what. That's why we have calculators. I'm much more interested in figuring out why certain patterns exist in number theory than to do sums or products. Which is why I'm always seeking for shortcuts. Calculating isn't fun, but sometimes it's faster to calculate something in my head than even to use a calculator. Or there are times when I don't have a calculator handy since my cell phone is charging in the other room or whatever. So I'm going to share with you one technique specifically for multiplication that has helped me do math a lot faster in my head. It does require you to know a bit about the factorization of numbers, and since I'm not crazy, that means for me it's about 2-digit numbers. Beyond that, it gets far more complicated. But think about what I said earlier. Who wants to calculate 13 times 8? That's not a fun number to calculate, especially in my head. I'll be honest, I do not have my 13 times table memorized. So there are a couple techniques that I could use for this. First, I know that 8 is pretty close to 10, and 10 times 13 is easy to calculate. It's just 130. You don't even have to calculate to know that, just slap a 0 at the end of 13. It's how multiplication by tens works, and if I have to explain that to you, this might be a little more advanced than you're ready for. So we know that 130 is what we would have if we had 10 sets of 13. We're supposed to only have 8 sets though, so that means we need to take away 2 sets of 13. Well, 13 times 2 is fairly easy to calculate. Doubling any number tends to be easy. 13 times 2 is 26, and since 26 is only 4 away from 30, it's easy to see that 130 minus 30 plus 4 gives us 104, which is our answer. It's a somewhat lengthy process to describe, but it's actually quite fast to do with practice. But there's another method I take when I see numbers like 13 times 8. First, I know that 8 isn't really 8. Or rather, 8 is 8, but it's also 2 times 4. And 2 times 4 is like an alias for 8. You can even say 2 times 2 times 2 is another alias for 8. But in this instance, 2 times 4 is a good enough alias for 8 for me to use. That's because, again, doubling something is easy. So the first time I thought about how to calculate 13 times 8 in my head, I thought to myself, well, 13 times 2 times 4 is what I'm really going for. And 13 times 2 is easy, that's 26. 26 times 4 is very close to 25 times 4, and 25 times 4 is a simple 100. We all know that because a quarter is 25 cents. So we have 25 times 4 to make our dollar, and we have an extra 4 cents left over since we need 26 times 4. Boom, 104. That's even easier than multiplying 13 by 10 and then subtracting the 26. So this leads me to my point that I'm making for this video. When I'm multiplying these relatively small numbers in my head, often what I look for is the factors of the numbers. If I have to multiply 15 by 16, I think 5 times 3 is being multiplied by 4 times 4. And then I can recombine the numbers. A 5 times 4 would give me 20, and I have the 3 times 4 left over, which is 12. 20 times 12 is simple since multiplying by 20 is the same thing as doubling the original value and then slapping a 0 at the end. So I double the 12, get 24, add the 0 at the end, it's 240. I can solve that in a fraction of a second mentally, faster than it takes me to type in the numbers on a calculator and hit the equal sign. And I am by no means a math Olympian or anything like that. I don't like calculating, and I'm taking the lazy way to do this. And of course, the big thing I should point out is all of this is definitely faster than writing it down on a piece of paper and then doing it the long way that we're taught in school. The long, boring, extra grindy way that, yes, it will give you the right answer, but you don't know what you're actually doing by just following the rules that are presented to you. Of course, there is a bit of an elephant in the room. You can't always find factors of numbers. For example, take 17 times 13. I was going to use 17 times 19, but that's just 17 times 20 minus 17. And we just mentioned multiplying by 20 is the same as doubling and adding a 0 at the end. Thus 17 doubled is 34, so we have 340 minus 17, or 323. So let's look at 17 times 13 again, even though this is making this video turn into a modified 13 times table. Anyway, both 17 and 13 are prime, so you can't find other factors for them. And it's at this point I'll seek out other shortcuts. I can use other numbers that are close to the ones I really want. 17 times 13 is hard, but 16 times 13? That's 4 times 4 times 13, and 4 is just 2 times 2. So we're doubling twice to get to 4. 13 doubled is 26, doubled is 52, just like a deck of cards. That gives us our first set of 4 times 4, so we're left with 52 times 4 remaining. Again, we double twice and we get 104, then 208. So 16 times 13 is 208. 17 is just one more set of the 13, so 208 plus 13 is 221. So here's the key. You can always find outpost numbers like 10, 20, 25, 50, 100. And if you're close to those values, you can edge towards those numbers as long as you remember to undo what you're doing to get there. And if you're on a prime number that's really weird, you can simply add or subtract 1 from it normally and make it at least an even number to see if that helps. Remember, doubling is way easier than doing the hardcore calculations. So let's give it a more complicated number as the final example of what I mean. We'll make it super high numbers. What's 97 times 91? Again, just pick one of the numbers and move towards a landmark. I choose 91 since it's close to 90, and 90 is 9 times 10, so we can start with the 10 and have 97 times 10, which equals 970. Now we have to calculate 970 times 9. Well, this we can just repeat again, because we know 970 times 10 would be 9,700. You can subtract 970 from that to get 970 times 9. Here, I'll do the same technique with addition that I do with multiplication. I'm not going to subtract 970. I'm going to just subtract 1,000 and then add 30. So 9,700 minus 1,000 is 8,700, plus 30 is 8,730. So we have 97 times 90 is 8,730, and we just need to add in our final 97 to make it our 97 times 91. Again, I'm going to add 100 and subtract 3. So that gives us 8830 minus 3, which is 8827 for our final result. So there you have it. I'm not going to lie and say that this is something you can instantly pick up, but if you try it a few times, I think you'll get the hang of how it works, and you'll be able to calculate better in your head. The tip I would give is to start slow and write down your work as you go. While the point is to make mental math easier, it becomes easier the more you play with numbers and become familiar with them. For instance, with the step where I subtracted 970 by subtracting 1,000 and then adding back 30, that sort of technique should become second nature to you. I do that now without even thinking about it because it's so simple to subtract 1,000, and it's way easier to add 30 than it is to try to keep 970 as a sacred entity that must be preserved and manipulated solely as it is. No, numbers have many aliases, and numbers that are adjacent to other numbers can help you with the more complicated math. If you're trying to break into a bank, you can try to crack the safe, or you can just go through the back door they forgot to lock. In the same way, if you're trying to multiply some complex number you can't factor, the number immediately before or after it might be extremely simple to use. Embrace your laziness and go for the easier method. Do less calculating and spend more time enjoying the awesomeness of number theory. And with all that, I hope you guys have a wonderful day. Peace out.